In this video, we're going to continue with the second derivative test. This is going to be the second part in a three-part series for this topic. And in this part, we're just going to do an example. Alright, we're going to apply the second derivative test. And so again, the goal is, so let's say you're given this function, f of x. It's going to be some polynomial, alright, 1/2 x to the fourth plus 2/3 x cubed minus 6x squared. And the goal is going to be to classify its critical points. Alright, let's classify its CPs. So, to find the so we're first of all going to have to find the critical points, right? So we're going to have to take the derivative and set it equal to 0. But then after that, we're going to have to take the second derivative and test the value of the second derivative at each of those critical points. And so what I like to do first is just to go ahead and start computing derivatives, because we know we're going to need both of them later. So f prime of x, what's that going to be? Well, we're going to get 2x cubed, then we're going to get 2x squared, and then negative 12x. Alright? What's the second derivative? Second derivative is going to be 6x squared plus 4x minus 12. Alright. Now I'm just going to do a little thing here. Alright, I'm going to factor f prime of x. And you'll see why I'm doing that in a second. So let's just go ahead and factor it. Let's pull out 2x. What do you leave behind? You leave behind a x squared and a minus x, plus x and a minus 6. Alright, so you see each of these terms has a 2x in it. If you pull it out, then what you leave behind is x squared, x, and a negative 6. Okay, so that's that. Now what are we going to do? First, let's find the critical points. So that means we need to set the first derivative equal to 0. So f prime equals 0 means simply that. So let me put it here. F prime has to equal 0. So we know that 2x squared plus x minus 6 equals 0. Alright? Well, if that's equal to 0, then that means either 2x equals 0, in which case x equals 0, or x squared plus x minus 6 equals 0, in which case what are the possible values for x? Well, there are two ways now you can do this. You could either use the quadratic formula, right? Or you can just continue factoring it. In this case, it's pretty easy to factor. It actually factors as x minus 2x plus 3. And why is that? That's simply because, well, the leading coefficient here is 1. It's quadratic. So in order to factor it, we know it has to factor as x plus something, x plus times x plus something. And we just have to find what those numbers are. And the easy way is just to find two numbers that multiply to negative 6 and then add to 1, right? Because that's the coefficient here in front of the x. So what two numbers are those? Positive 3 and negative 2. Okay, and so if 2x times x minus 2 times x plus 3 equals 0, that means either x equals 0, or x is equal to 2, or x is equal to negative 3. Alright, and those are our critical points. Here we go. Circle them. So those are our critical points. Okay. So that's the first step, and now what's the second step? We're going to just take these values and test them in the second derivative. So step 2 is going to be to test. Test f double prime of c. And so we have three values here. What's f double prime of 0? Well, that's really easy. Here's f double prime. If we plug 0 in, we're going to get 6, where the x squared term is going to go, the x term is going to go, we just have negative 12. Right, so right here, I'm looking right here. Here's the second derivative. And then you go to x equals 2. Well, let's see, what is that going to be? 6 times 4, that's going to be 24. We're going to get 4 times 2, that's going to be 8. And then we're going to subtract 12. And so 24 plus 8, that's going to give us 36. 24 plus 8 is going to give us 32. And then when we subtract 12, we're going to get 20. Okay? Finally, we go to negative 3. If we plug that in, let's see what we get. We're going to get 6 times 9, that's 54. Then we're going to get minus 4 times 3, which is 12, and then minus 12 again, but that adds up to negative 24, and so you're going to get 30 here. Alright, so let's check this out. The value of the second derivative at 0, this is negative. And so what does this mean about your function? That you must be concave down. You're concave down and you have a critical point. What does that give you? That gives you a peak. Remember? So this gives you a peak because we have concave down and we have a critical point. So that means right here we have a peak. Alright, let's go to f of 2. This is for x equals 0. If you go to x equals 2, then you have the second derivative there being positive, so it's concave up. And you have a critical point, so it must look like this. So it must be a trough or a relative min. That's x equals 2. And similarly, when you get to x equals negative 3, the picture is the same. You have a critical point, so tangent line has slope 0, but the shape of the graph is concave up. And so at x equals negative 3, you have a trough, or another relative min. And that's how the second derivative test works in this example. Again, we're just testing the values of the second derivative at the critical points and seeing if they're positive or negative.